Today we'll be factoring higher order polynomials. So we have been factoring quadratic polynomials so far. Quadratics have the highest exponent of 2. Today we're going to be looking at exponents higher than 2 and how we can factor those. So you're going to make sure that the polynomial is in standard form, factor out any common terms or the GCF, and then factor using one of the methods that we've learned so far, grouping, AC factoring, and difference of squares. So you just need to keep factoring until no other factors can still be broken down. So none. You can tell you have completely factored a polynomial when none of the remaining factors can be broken down. All right, so let's look at number 1. Number 1, now I'm going to look at my options here. My options are grouping, AC factoring, or difference of squares. We also have the option of factoring by GCF. That's not written up here. I'm going to add that. GCF. You can also factor by GCF. Okay. So looking at this one, I can tell right away that this is a difference of squares because x to the power of 4 can be, we can take the square root of it and we can take the square root of 36 and there's a subtraction sign. So I'm going to take the square root of x to the power of 4 and the square root of 36. The square root of x to the power of 4 is x squared because the square root of 4 is 2. And then the square root of 36 is 6. So I'm going to get my two sets of parentheses, one with a plus, one with a minus. And now I have factored that polynomial. Number 2. Let's see. So I can't do a difference of squares because 5 you're not able to take the square root of. But I notice they both have x. So I'm going to factor out a greatest common factor before I do anything else. Now, check to see if the bigger number can be divided by the smaller number. And if it can, then you're going to factor out that. So the greatest common factor of 9 and 144 is 9. And they both have x. The lower exponent is 1. So I can factor out 9x. When you divide, you get x to the power of 4 minus 16. Now, x to the power of 4 minus 16 is a difference of squares. So I'm going to take the square root. Square root is x squared and 4. So now I have to keep checking. Is there anything else that can be factored? You should be able to recognize that x squared minus 4 is another difference of squares. So you can do this one again. X squared, the square root is x. The square root of 4 is 2. So now in my final answer, let's see. I'm going to write this a little bit bigger. I have 9x times x minus 2 times x plus 2 times x squared plus 4. And x squared plus 4 cannot be factored. So that is my final answer. Number 3, we have a trinomial. Highest exponent is 4. So we can't use difference of squares. They do not have a common factor. I can't factor by grouping until I break it down into a 4-term polynomial, so I need to use the AC method. So in my top number, I'm going to have A times C, so negative 15, and bottom number is 14. Top number is negative, so one of my factors is negative and one is positive. So I will use positive 15 and negative 1. When I add those together, I'd get 14. Separate the middle term to negative 1x and positive 15x. Oops, sorry about that. Remember that this is x squared. Very important when you're doing higher order polynomials that you remember to use the correct exponents. Now I can factor by grouping. So I'm going to factor out x squared because that's my lowest exponent. So I get 3x squared minus 1. And here I'll factor out 5. Oops, not negative 5. Three x squared minus 1. 3x squared minus 1 times x squared plus 5. Number 4, another trinomial. Now in this trinomial, a is equal to 1, so we can use a shortcut. If you remember that when a is equal to 1, you don't need to fully factor by grouping, you can just solve the x puzzle. So my top number is 18, bottom number is negative 11. Top positive, bottom negative, that means both factors are negative. So negative 9 and negative 2 is the answer here. Now, because a is equal to 1, I can go straight to, now remember, we need to use x squared, that middle term. So we're not going to just do x minus 9, we're going to do x squared minus 9 times x squared minus 2. You can factor by grouping. You would end up with this answer, but there is a shortcut when a is equal to 1. My son's alarm clock is going off. Okay, now recognize here that we have a difference of squares, x squared minus 9. So take the square root of x squared, you get x. Square root of 9 is 3. So we have x plus 3 times x minus 3 times x squared minus 2. Okay, number 5. We have some big numbers here, so always check to see if you can factor out a common factor. I can factor out 5 from all 3 terms. So now I have a trinomial where a is equal to 1, so I'm going to use the shortcut here, negative 63 and negative 2. my solution is -9 and +7. So remember, again, don't forget to use the middle term, x squared minus 9 and x plus 7. I have a difference of squares with x squared minus 9 again. So now I have 5 times x plus 3 times x minus 3 times, oops, I forgot the squared there, x squared plus 7. So whether you use the shortcut or you factor by grouping, just make sure when you split the middle term is squared in higher order polynomials. So you have to split that squared and make those terms x squared, not x. Okay. Number 6. I can factor out 3x because x is the lowest exponent and they all the terms have x. So 3x, this gives me x to the power of 4 minus 3x squared minus 28. Again, I have a equal to 1, so I can use the shortcut. Let's see, 28, 7, and 4, so -7 and +4. So I have 3x times x squared minus 7 times x squared plus 4. Now check to see if there's anything else that can be factored. And x squared minus 7 is not a difference of squares, and x squared plus 4 is not a difference of squares. So I am done. Okay. Number 7. I don't have any common factor for all 4 terms, so I'm going to factor by grouping. Factor out x squared and I have x to the power of 3 plus 5. And then I'll factor out -4 x to the power of 3 plus 5. And I can recognize that that is a difference of squares. So take the square root, and now I have x to the power of 3 plus 5 times x minus 2 times x plus 2. Okay, last example of the day. I know right away that I can factor out 2. Oh, and I just noticed that this is not in standard form. So it doesn't have to be in standard form. We could switch these, but I kind of like the 16 and the 32 next to each other because I know that 16 is a common factor. I think I'm going to go ahead and leave those in that order and factor by grouping. Factor out x squared So now I have 2 x squared x to the power of 3 plus 2 factor out -16 x to the power of 3 plus 2. So now I have 2 times x to the power of 3 plus 2 times x squared minus 16. And x squared minus 16 is a difference of squares. So take the square root. So I have 2 times x cubed plus 2 times x minus 4 times x plus 4. So the trick to these higher order polynomials is just keep looking for something that can be broken down further. Really recognizing difference of squares is going to be crucial here. So that is what you'll be doing in today's practice.